questions 1 through 4 on the 2011 grade 12 Euclid math contest. If x plus 1 plus x plus 2 plus x plus 3 is equal to 8 plus 9 plus 10, what is the value of x? Some of you will be able to do this question by inspection, but let's just do it the long way. The left side will become 3x plus 6, and the right side, if you add those up, is 27. 3x therefore is 21, and therefore x is equal to 7. If the square root of 25 plus root x is equal to 6, what is the value of x? Root 25 plus root x is equal to 6. So the first thing, of course, square both sides. If you do that, you get 25 plus root x is equal to 36. Then bring the 25 over to the other side, and you get 36 minus 25, which is 11. Then again, take the square root of both sides, and you get x is equal to 11 squared, which is 121. The point A2 is the point of intersection of the lines with equations y equals 2x minus 4 and y equals x plus k. Determine the value of k. Well, these two lines, y is equal to 2x minus 4 and y is equal to x plus k, intersect at this point. So let's substitute those points in and get some values. So a2 into this first equation, a for x and 2 for y, gives me 2 is equal to 2a minus 4. And if you do the same thing, plugging in a2 into that equation, you get 2 is equal to a plus k. And we can now solve, because we have two equations and two variables. So in the first one, this guy right here, we can just solve for a. It will be 6 is equal to 2a, and therefore a is equal to 3. And then substitute that back into here, and if you do, you get 2 is equal to 3 plus k, and therefore k is 2 minus 3, which is negative 1. And that's it. An equilateral triangle of side length 1 is cut out of the middle of each side of a square of side length 3 as shown. What is the perimeter of the resulting figure? Well, the whole square has a side length of 3, and the triangle has a side length of 1. So that means that this is 1, and so is this, and so is this, because it's equilateral. And the same story holds true for all of them, right? If you just, in a very basic way, make this diagram, those are all 1s like that. So the perimeter is going to be just the black lines. And I'll label those. If this whole thing was 3 and you cut out 1, that means this and this add up to 2. And we can just put 1 and 1 on either side. And the reason we can do that is because they're saying that it's cut out of the middle. So similarly, this is 1, 1, 1, 1, 1, 1. So the perimeter would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Perimeter is 16 of that shape. In the diagram, DC is equal to DB. The angle DCB is 15 degrees, and angle ADB is 130. What is the measure of angle ADC? Well, let's first plug in the values they give us. DCB, this guy is 15, and ADB, this one, is 130. This symbol means those two are equal. So that means this angle is the same as that angle because it's an isosceles triangle. So that means this angle is also 15. Now this angle must be 180 minus those two. 180 minus 15 minus 15, because the sum of the angles of a triangle equal 180. So that means that angle will be 180 minus 30, which is 150. So put 150 right there. And then now they want you to figure out ADC, which is this angle right here. Well, all of the angles all the way around have to add up to 360. So that means angle ADC plus that 130 plus the 150 all have to add up to 360, like that. So solving, you get ADC is equal to 360 minus 130 minus 150, and if you do that, you get 80 for ADC. In the diagram, EAD is 90 degrees, ACD is 90, ABC is 90, ED is 13, EA is 12, DC is 4, and CB is 2. Determine the length of AB. Well, this is a whole bunch of Pythagorean theorems. Some of you can do this in your head since these are very common. But if you can't, no problem. 12 squared plus AD squared is equal to 13 squared. Solving, you get AD is equal to 5. And then now we'll concentrate on finding AC. And like I said, it's a 3, 4, 5 triangle. If you're in grade 12, you definitely know that. But if you didn't, you can always use Pythagoras. And solving this, you get AC equal to 3. And then now we have to figure out AB. So again, using Pythagoras, AB squared plus 2 squared is equal to 3 squared. So that means AB squared is equal to 9 minus 4, which is 5. And therefore, AB is equal to the root of 5. If x is between 2 and 5 inclusive and y is between 10 and 20 inclusive, what is the maximum value of 15 minus y over x? 15 minus y over x is what you are trying to maximize. If you want to maximize that, you want to minimize this. So we want to minimize the value of y over x. If you want to minimize that, obviously you need to minimize y and maximize x. So based on the range they gave us, the minimum value of y is 10. And again, based on the range they gave us for x, the maximum is 5 for x. So this becomes 15 minus 10 over 5, and that is 15 minus 2, which is 13. And that's going to give you the maximum value for that expression. The functions f and g satisfy f at x and g at x. Added, 3x plus 5, f at x minus g at x, 5x plus 7, for all values of x. Determine the value of 2 times f at 2 times g at 2. Several ways of doing this. There's a short way, and I'll show you the short way. The first is just to add these two equations. If you do, you'll notice you'll get 2f at x. The g at x actually cancel when you add. On the other side, you'll get 8x plus 12. Now, we are interested in f at 2. So put in 2 for x, and you get 2f at 2 is equal to 8 times 2 plus 12. And that is 16 plus 12, which is 28. For 2f at 2, right? And if you want to, you can divide through to get just f at 2, which would be 14, right? Either way. Now we do for something very similar. We take these two equations and subtract them. So this minus this. So it would be f at x plus g at x minus f at x minus g at x, which would be plus g at x. And then on the other side, same thing, it would be 3x plus 5 minus 5x minus 7. So this side, the f at x, both of them cancel each other out, and you just get 2g at x. And on this side, you get minus 2x minus 2. Well, we are interested in g at 2. So 2g at 2, substituting 2 for the value of x, is minus 2 times 2 minus 2. And this looks like minus 4 minus 2 minus 6 for 2 times g at 2. And we can divide through by 2 to get just g at 2, which will be minus 3. There you go. Now we want this whole thing. So we want 2 times f at 2 times g at 2. That's going to be 2 times f at 2, which is 14. G at 2 is negative 3. 2 times 14 times negative 3 is negative 84. Three different numbers are chosen at random from the set 1 through 5. The numbers are arranged in increasing order. What is the probability that the resulting sequence is an arithmetic sequence? An arithmetic sequence is a sequence in which each term after the first is obtained from the previous term by adding a constant. For example, 3, 5, 7, 9 is an arithmetic sequence with 4 terms. Well, 1, 2, 3, 4, and 5 are the terms that we are going to select from. And if you just, you can do this manually because there isn't that many of them. But if you're wondering, if I have to select 3, I've got 5 choices for the first one. Then they have to be different, right? So the next one I only have 4 choices, and then the third one only 3 choices. So 5 times 4 times 3 is 60. Now 60 is a lot, but the good news is that you divide by 6. Why? Because if you selected any of them, if you made any combination, let's say I chose the 1, a 2, and a 5. Okay, those are my 3 numbers that I selected. There's 6 possible combinations for this. 1, 5, 2, 2, 1, 5, 2, 5, 1, 5, 1, 2, and 5, 2, 1. So as you can see, if you select 3 numbers, those 3 numbers have 6 possible combinations, and we just want unique ones. So that's why you divide by 6. And when you do, you only get 10. And that's good because we can manually figure those out. So let's just write them over here. The first one, 1, 2, 3. And the next one, 1, 3, 4. Then 1, 4, 5. 1, 2, 4. 1, 2, 5. And 1, 3, 5. And then moving on to 2's, we get 2, 3, 5. 2, 3, 4. 2, 4, 5, and 3, 4, 5, moving on to the 3. So there's only 10, as you can see. And I encourage you to sort of come up with that list on your own. Now, you say, well, why don't you include other ones? Like, for example, 4, 2, 1. Why wouldn't you include those? Because the numbers are arranged in increasing order. So that's why something like 4, 2, 1 would not be in our list. So now that we have 10, we know for sure that the probability is going to be something over 10, because the denominator in a probability question is always the total number, and our total number is 10. But the numerator is going to be how many of these 10 match our specific condition. And in this question, the specific condition is that the numbers have to create an arithmetic sequence. Okay. Well, an arithmetic sequence basically means it's of the form like this. A plus D, A plus 2D, and so on. A plus 3D, A plus 4D. So that means that if you were to take the second term and subtract from it the first term, A plus D minus A, you just get D. You get D. And then similarly, if you take the third term, which is A plus 2D, and subtract from it the second term, which is A plus D, right, I'm subtracting, that's why it's going to be minus A minus D, then again you get just the D. So that means the difference is what you get when you subtract consecutive terms. So we have to do the same thing. Now, some of you can probably do this very quickly. For example, this first one, the difference for each of them is 1. When you go from 1 to 2, it's 1. From 2 to 3 is 1. So that is indeed an arithmetic sequence. This one, you're going from 1 to 3, which is a difference of 2, but then you're going from 3 to 4, which is a difference of 1. Those differences do not match, so that is not an arithmetic sequence. Similarly, this one, you're going from 1 to 4, the difference of 3. Then you go from 4 to 5, difference of 1. Those differences do not match. This doesn't match, and this does not match. But the next one, this one, when you go from 1 to 3, it's a difference of 2. When you go from 3 to 5, it's also a difference of 2. So that is indeed an arithmetic sequence. And similarly, you'll notice that this is an arithmetic sequence with a difference of 1 that's common, and so is this. This is also has a difference of 1. This one had a difference of 2, and this one had a difference of 1. So 4 of them are arithmetic sequences, so our probability is 4 over 10. In lowest terms, it would be 2 over 5. In the diagram, ABCD is a quadrilateral with AB equal to BC equal to CD equals 6. ABC is 90 degrees, BCD is 60. Determine the length of AD. Well, I will first draw a line from B to D like that. And that line will help me in the following way. First, this angle is 60 and these two are equal. So that means that this angle is the same as that angle because that is an isosceles. So let's just call this theta and let's call this theta. That means 2 theta plus 60 is 180 degrees. 2 theta therefore is 120 and theta is 60. Well, if theta is 60, then that means these are 60, 60, 60. So instead of theta, let's put in 60 degrees, and that pretty much tells me that's equilateral. So that means this is also the same. And they gave me some lengths, right? They told me that BC is 6 and CD is 6. So that means BD is also 6. Now, they also told me that AB is 6. So that means this triangle is isosceles. So that means that this angle, if I call it alpha, is the same as that, alpha. Now this angle in here is going to be required, and we can figure that out easily because they told me that was a right angle. There's a right angle symbol there. And if this is 60 and that's 90, that whole thing, then this must be 30. So there you go. So that means that 30 plus alpha is 180, 2 alpha is 150, and therefore alpha is 75. So instead of those alphas, I can put in 75. Now I'm not really even sure if that's needed, so let me just hold off on that. It might be needed, but we can always put it in later. Now what I'm going to do is draw a perpendicular from B to AD so that it touches at a right angle like this. Now because it's an isosceles triangle, that right angle, or that line that creates the right angle, chops AD in half. So the distance from here to here is just half of AD. Now we can use Pythagoras or we can use trigonometry. This whole angle was 30, right? This green line chops it in half, that angle. So this becomes 15. And now we can use trigonometry fairly simple on this triangle right there. The sine of 15 will be equal to opposite, which is AD over 2, this distance, over hypotenuse, which is 6 right there. And there you go. So if you were to just isolate for AD, you get 6 sine of 15 is equal to AD over 2, and therefore AD is equal to 12 sine 15. Now you can leave it in this format, or you can just take out your calculator and figure out the actual numerical value. It's 3.1058 to 4 decimal places. Either way, those are correct answers.